Hi, hello everyone. Today I am going to do a simple check using SAP 2000 software about the shear force and bending moment diagram. Okay, here there are four questions. So I am going to check about one question. If you need other questions as well, so I can explain. So just I am going to move with this one, right? I am going to move with this one. We will see whether the results are same or not, right? So using the SAP 2000 software, and what are the difference between manual analysis? This one is from manual. So let's see whether both values are same or little closer or very far difference is there, or let's see whether can we use that one for our very big situation problems for beam design as well. Okay, let's move to the SAP 2000 software for this question, right? So there are, how many spans are there? Only one particular span. So I am going to take, there are A, C, D, B. So just for the moment, you can understand finally. So just for the moment I'm going to take, there are, as there are three spans, right? So just move there. So click file and new model first, then you can select the unit first, kilonewton meter centigrade, then Europe or what, any other materials you can select. Just default material I'm selecting, then beam. So I'm going to move with the template of beam for because of beam question. Then I already told you there are three span I'm going to take, then span length. So just I am moving with, say, the span length is 413, right? So I'm taking 4 now. Then beam, the material, the section property of the beam I'm not going to give it here. I'm just selecting a default, right? If I need, I can give that one as well. So I'm not going to move with the sectional properties, right? Also the material properties as well, right? So just clicking OK. By clicking OK, there are, you can see 1, 2, 3 spans, right? So at this particular position, I am not having any of here, any of the supports at here, right? So I have to move to the assign menu, joint, restraint. There is nothing, right? So just node and apply and OK, right? So only we can see two nodes and only two supports. In my question, one particular place there is, right, there is a pin support, and here there is a roller support, right? So pin and roller support are here. So here I need pin, right? So already it's there. Just if you need any other, go assign join restraint for fixed, for pin, for roller, right? So already pin is there, right? So if I want, just I can click that one and apply, then OK, right? Here same assign join restraint roller apply OK, right? So it's already there. We don't need to give that one. Just I'm showing how to give that one, right? So now in my question here, so A to C, there is a 2 kilonewton per meter UDL is there, right? So now for the UDL, so what the spacing is not the same, right? I already told you it is 412. So just clicking by here in this frame, just, so otherwise outside, right? Outside, edit, right click. Okay, here you have to give interface, right click, right, working space, right click, edit grid data, and so you have to click right click and you have to select edit grid data, then modify source system. So now the values are there, right? So values are there. So I'm not going to move with the ordinates, so I'm going to move with the spacing. Just click spacing. Now all things are 4. I already give 4, no, span length is. So now in my question 1 2, right, 4 1 2, 4 1 meter and 2 meter, right. Now just click OK, right. After just click OK. Now the thing you can see there, right? So there is a thing you can see there, right? So apart from this, so beam length, right? You don't need beam length apart from this, right? So just I am clicking here and I am going to delete these 2. I don't need that 2 frames. So I want to draw that one, right? So click that line and here, so just I have to draw again, right? Now there are 3, there is now here you have to assign, yes, sorry. Now here you have to just assign restraint, roller support, yes, okay, right? Just sorry, here, right? Have to select this one, then assign, join, restraint, roller support, right? Apply, okay, right? Now we can see our questions typical model is now we have, right? So next I have to give loads, right? So there are UDL 2 kilonewton per meter between A to C, and at D there is 5 kilonewton, right? Point load is there, right? Point load is there. So point load is there at D. So just I am going to give point load, right? So before going to there, just define load patterns. Go to the load pattern first and give live load. If you need live load, live, and here you have to add new load pattern. Now dead and live are there, okay. Then define load cases. So now the load cases live is there, right? So live is there. We have live load cases. If you need, you can give any other as well. So just modify, you can see live load pattern also there, right? So now you can see, now what you have to do is you have to go assign here, join forces, assign join load forces. Here what I have to give is just I'm selecting like a live load, global one, and here at this particular place I'm going to give load, right? Here I'm selecting that particular place first, right? So I have to select that particular place there. Sorry. Yes. So at this particular place I have up to this on this member, not at this particular place, on this member I have UDL, right? So I have to select that one, assign. Here there is a frame load of distributed, so I am giving a like live, right? So global, so gravity, it's from downward direction, so just I can give the gravity load, and here it's a UDL, no? So otherwise I can if it is not a UDL, so I can mention at this relative distance at trapezoidal loads as well, right? So different consideration I can give it here as well, right? So here UDL, for UDL I have what, 2 kilonewton per meter, so just selecting 2 and apply and OK, right? So now you can see the 2 kilonewton per meter, right? So at this particular point, what I have to say, I have to give is assign join load, assign join loads, forces, live, right, global. Here it is in Z direction, right, opposite Z direction. So in Z direction negative, how much the value is? The value is 5, right? So minus 5, right? Minus 5. So apply, replace existing load, apply, OK. Now the loads are there, right? Now our work is finished, right? So just go and check. We will check whether same diagram, same values are there or not, right? So just move to the analysis, then run analysis, right? So run now, right? So first of all I have to serve this one. So BU example, right? So I'm serving this one here, right? 2.0, right? Okay. Now after serving this one, the model is going to analyze it, right? So after analyzing this one, our deflected shape is there like this, right? So here, so you can get diagram, show forces and stresses here is there. So deflected shape also you can get by deformed shape you can get from here. So undeformed shape if you need, you can select that one as well. So here for this drawing, right, here I am selecting and frame cable tendon. Here you have to select this one here, right? So in this place, so just select live and you have to give, if you need shear force, shear 2 and if you need by filling diagrams or values, I will show that one as well, right? So if you need fill diagram method, if you want to see, so apply and OK. So this is the way you can see the values and the diagram of shear force diagram. So let's see whether it is same or not, right? Is it same? No, right? So it is not same like this. But the thing is, it's same, but the problem is here it is in opposite direction, right? It is in opposite direction because of the sign convention, right? So because of the sign convention, here you can see this one is going to get, it is in above here, right? So the thing, this side is below, right? Right? It is there, right? Let's see the values. The values are here, the maximum value is near to 5.86, right? 5.86. Let's see here. Let's see here. It is near to, whether it is near to the 5.36. Let's see. Here the value. So move there again and select this one and show values. Then apply and OK. Now you can see the direct values as well. So if you need to get this one little bigger one using this rubber band zoom, you can select this one. Sorry for that. So now you can see the values, right? So now check the value here. Yeah, 5.86, right? Yeah, 5.86. Nice. This is plus, but this is negative, right? That's only the problem. Here 0.86, right? 0.86, right? Here, if you come close to the 0, here 7.14, right? Here it is 7.14, right? Same, but it's negative, but because of the sign convention, right? There's no any problem. So because of the sign convention, it's giving the values, right? So let's see about the bending moment diagram here. Frames, same way. So bending moment diagram, moment 3, right? Apply and OK. Let's see about the bending moment diagram, right? Here, yes. Here it's also according to the sign convention issue. So the value here is 12.75, right? Here 12.57, right? Here 11.71, right? 72, but little closer, right? The value is little closer. 5.6, but this is 5.7, 12.75, same, right? So this is actual values you can get from there, right? If you want at this particular distance also, here 12.75, this is the value, but if you need a particular correct distance, okay, correct 5.6, say correct distance of this one, here you can click at here, you can select that particular position, right? Yes. So in this diagram, these values are here. You can see all the values of that one, right? Shear force, sorry, bending moment, right? So this is how you can do the analysis using a particular software, right? SAP 2000 software. Here what I am saying, what I am going to mention you is the same values are not equal, right? Because of some issues. Because here you can see when we are doing the manual analysis, we are assuming that a member not have a self weight, right? So there is a weight we are assuming there, right? But actually, we know member have self weight. So if you consider that one, your diagram will be like this SAP 2000 way, right? So because this answer will become like that, right? But here for the manual analysis, we are not considering that one. So that the kind of a difference is there. But actual, the correct, the reading, okay, the diagram is SAP 2001 because it's included the correct all the loads, right? So this is what and how you can do the analysis, right? If you want more videos, okay, little more videos or little more calculations for these as well, so if you need, you can put a command and I am ready to do another next sessions as well. Okay, then thank you for watching my video. Feel free to give your comments further any doubts or anything else, right? Thank you very much.